Listen, this theorem states that for any simple undirected graph, that is very important. Simple graph means it don't have any loops. I explained what is the loops. Consider the graph V1, V2, V3, V4. Loop means this is a loop. Simple graph means without loops. There is no loop will involve. Okay. For any simple undirected graph G with n vertices. So it is an example problem. 4 vertices. In generally, we will say n number of vertices. The number of edges of G is less than or equal to n into n minus 1 divided by 2. We have to prove this one. First, you have to understand the concept. N number of vertices, and we have to take the edges. Number of edges we have to note it. Then we have to prove number of edges of the graph is less than or equal to. If you take E is the number of edges of the given graph, then less than or equal to n into n minus 1 divided by 2. We have to prove like this. E represents the number of edges of the graph. So here edges E1, E2, E3, E4. Okay. Listen, to start the proof, we have to take the statements from the theorem. Let we have to take. Here they have given simple undirected graph. G is a, let G be a, because we used let, so we have to use B. Let G be a, let G be a simple undirected graph. G be a simple undirected graph. Okay. Write many statements, then only you get to much marks. Okay, so take the words from the graph. They have given. Let G be a simple undirected graph, and n number of vertices, because in column itself they have given n vertices, n number of vertices, and they didn't mention the edge, so we have to take edges, comma, E number of edges, E number of edges, E number of edges. E represent the number of edges, E represent the number of edges. N always represent the vertex, number of vertex. E represent number of edges. We know that for simple graph, degree of V less than or equal to n minus 1, because n represent the vertex, number of vertex. So degree should be equal to equal to n minus 1 or less than n minus 1. Consider what is degree of V1. What is degree of V1? Adjacent vertices 1, 2. 2 adjacent vertices are there. So 2. So 2. What is the total number of vertices? What is total number of vertices? 1, 2, 3, 4. 4. Which is less than or equal. It should not begin less than or greater than this one. Okay. It must be less than number of edges. And what is utmost degree? For example, utmost degree. What is the degree of V1 for this graph? 1, 2, 3. So degree of V1 is 3. Degree of V1 is 3. What is the total number of vertices? 4. Total number of vertices? 4. So 4. So this is a maximum one. So this can be written as, in generally we can write V1 n, which is, sorry, V1 is less than or equal to n minus 1, because this is n, this is n minus 1. It carries the utmost degree. Okay, so degree of V1 should not equal to n or greater than n. The degree of V1 should be less than or equal to n minus only. Okay, should not cross total number of vertices. So any degree of the graph should not cross the total number of vertices of the graph. Okay, total number of vertices of the graph. Utmost degree will be n minus 1. Utmost degree will be n minus 1 because of the evidence. Okay, utmost degree will be n minus 1 or less than n minus 1. So less than or equal to n minus 1. Here it says for simple graph means there is no loop. Loop should not involve. Here given, they are given simple and directed graph. It's applicable only for simple and directed graph. For simple graph, degree V less than or equal to n minus 1. Take it as 1. Take it as 1. By handshaking theorem, sum of I equal to 1 to n, degree of Vi equal to 2 into number of edges. 2 into number of edges. Next, we have to expand. It's for your understanding. Don't bring these things in main work. You have to do this work for your understanding. Okay, so we have to split the note into 2 parts. You have to write rough work inside, not in main work. Okay, just listen. We have to expand. We have to expand this one. Degree V1, because I start with 1. Summation represents sum. We have to plus degree V2, degree of V3 plus etc. degree of Vn equal to 2e, equal to 2e. 2e equal to, just write like this, degree of V1 plus degree of V2 plus etc. plus degree of Vn. From 1, listen, any simple graph satisfying this condition. Any simple graph satisfying this condition. Okay, so instead of degree V1, we can write n minus 1. If you enter this n minus 1 here, automatically it will bring this condition. So 2e less than or equal to, instead of degree of V1, we can write n minus 1 plus, instead of degree of V2, we can write n minus 1. Actually, it is not equal to n minus 1, but less than or equal to. Keep that in your minds. Degree of V1 is not equal to n minus 1, but n with less than or equal to n minus 1. Okay, less than or equal to n minus 1. Next, plus etc. What is degree of V1, which is also less than or equal to n minus 1. Here less than or equal to. If you take any vertex, these are V1, V2, V3, V4, this condition will satisfy. Degree of V1 is 3, which is less than or equal to total number of degree 4. Okay, that is n minus 1. Less than or equal to n minus 1. V2 also satisfy this condition. V3 also satisfies this condition. So that only we are applying here. So instead of degree V1, we can write n minus 1 because of the less than or equal to condition. Okay, so next. 2, next, this equal to, not less than or equal to, but this condition is an n minus 1 plus n minus 1, n minus 1 how many times? N times. N times. How you can take this is a n times? Because we expand the term from where to where? 1 to n. So 1 plus 1 plus 1 plus up to n times, like that. N minus 1 plus n minus 1, n minus 1 up to which time? N times. 2 plus 2 plus 2 can be written as 3 into 2. Yes, 3 times. So what is n minus 1 plus n minus 1, etc. n minus 1, n times? What we can write? N into n minus 1, because n time. Here 3 times 2. We have to sum 3 times 2. So we can write 3 into 2. So n times n minus 1 can be written as n into n minus 1. N into n minus 1. Next. 2e less than or equal to, this only equal to this value. So n into n minus 1. Bring denominator 2e divided by n less than or equal to n minus 1. What's our theorem says? So e less than. Oh, okay, bring 2 right hand side. E less than or equal to n into n minus 1 divided by 2. Divided by 2. Hence proved. You have to write the statement. Okay, you have to write the statement and say that hence proved. Okay.